Yeah, so I'm going to talk a little bit about cover crops and weed control. So maybe what you've been hearing a lot about is soil health with cover crops, and I think that's important, but I think from my perspective, it's not just soil health, it's weeds. And how can we use cover crops to keep weeds down, to control weeds, to kind of combat weeds. So I'm actually just a little bit about myself. So I've been here at USU for about a year. Before this, I was at Cornell University. I was joining a grants program, adjunct faculty member. I was in the Midwest for a while. I was at the University of Nebraska. And, but my point of talking about that is I've seen cover crops in different situations. And I've seen them work, and I've seen them be very effective. And I'm here at USU not to say cover crops are going to end or solve all the problems, but more to see, can cover crops be one of those tools in our integrated weed management plan. So I'd like to give some acknowledgement to my colleagues here, Earl Creech, Corey Ransom, and Danny Thiemann, and then Don Morishita at the University of Idaho are all part of this project. So a little background, or this is the outline I'm going to follow, and I'm going to talk about just give you some background about agronomic situations here in Utah, which you probably know enough about already, but want to address that a little bit. Rationale, some study sites, show you where we're doing our research, talk about some of our results, and then the implications of what we're seeing in the field. All right, so I think it's pretty obvious what we grow here in Utah. Livestock, whether that's dairy, beef, hay, alfalfa, wheat, corn, barley, safflower, everyone grow or have some connection to one of these, correct? Either grow crops or livestock. Anyone in the tree fruit industry? Got any cherry growers, peach? Maybe some backyard folks? Okay. So you know, there's a nice agricultural mix of products here in Utah. The growing regions, this is kind of a nice cartoon to show you where, it's dispersed throughout the state. I know this is not 100% accurate as far as, how much is grown where, but just to give you an idea of some of the other things, the other counties that are growing these different commodities. And the different regions. I'll talk about that, why that's important here in a little bit. As far as crop management, and obviously my interest is in weeds, so I'm going to tell you about weeds. And some of the major weeds you can see up here. Did I capture, does everyone's favorite weed, is it on here? No? Okay, I shouldn't say favorite, maybe your least favorite, your worst weed, is that on here? Okay. Well, if it's not, you could fall in the others category. But here's a number of different weeds that we deal with in agronomic situations. Whether it's pigweeds, grasses, purslanes, plantain, Russian thistle, we've got different foxtails, common lamb's quarters, mallow, prickly lettuce, bindweed, and kochia, and then there's a bunch of others. But I tried to pick a nice swath here to show you that we've got some diversity of weed species, and really some of these are really challenging, especially when you get into bindweed and some of the problems that it creates. But also, I want to emphasize that this cover crop approach is not just addressing one weed. You find the right cover crop or you find the right mix, you can actually address multiple weed species. And again, I'll talk about that here when we get into my research. So losses, dollar figures for losses associated with weeds. These are really difficult to quantify monetarily. But they do result in a direct reduction of productivity or usable acres. There's also harvest efficiency. So things like when you're trying to harvest a crop and there's weeds that are in the way or causing problems, that's going to reduce your efficiency. Indirect increases in things like inputs. That's a pretty obvious one where herbicides are one of our important tools. And also post-harvest processing, if you're producing things like potatoes or something where there's weeds in there, and then following that, you're going to have an issue trying to deal with them. Okay, so there's some monetary relationships here. And there's been some research to show that some of the different losses in the U.S. I'm just going to scroll through here. So in 1985, looking at some of the numbers, $8 billion related to weed competition. $2.1 billion for herbicides, and that's not just $4, it's actually $4 billion for equipment and labor. 1990, $110 million for livestock production and economic effects from leafy spurge. And then in 2000, these are some of the most recent numbers. I know it's still 18 years old or 19 years old. Control cost of $5 billion in pasture weeds, $1.5 billion lawn and garden, and $3 billion in crops. And that's just control costs. That doesn't account for actual crop losses, which in this case is $23.4 billion. Okay, so a lot of money here, which I think you guys all know that's part of the situation. But I think what's really, does anyone grow onions? Any onion growers? We had 2 onion growers in my last session. Onions do not compete with weeds at all, because as you know, onions grow straight up, and so there's not much for competing with weeds. So that number, 2,355% increase, is an actual number in non-weeded versus weeded onions. So really important aspect of weed control. Okay? So harm caused by weeds, what do? They harbor pests, reduce the quality of farm and animal products, whether it's contamination, toxicity, loss of acres, harvest efficiency, processing. They also affect irrigation. They either consume water or they plug up irrigation canals. They cause allergic outbreaks. Anyone that has ragweed issues, you know what I'm talking about. Fire. We're seeing a lot of changes in our fire regimes out in our natural areas, and that's in somewhat related to weeds. And they generally lower land values, especially if you talk about urban situations. But the thing that I'm going to focus on in this presentation is looking at competition for nutrients, water, light, and space. So how do these weeds compete for these resources at the expense of the crop? And what can we do about it? So we talk about this term integrated weed management. I think everyone knows what integrated weed management is. This is just a kind of a review related to integrated pest management. But it's an approach to managing weeds that promotes the use of a variety of tactics in a way that's economically beneficial while minimizing health and environmental risks. So what's in a toolbox? Well, we've got a number of tools that we use, and it's going to come up here pretty soon. There we go. There's cultural, chemical, mechanical, and biological. And so those are their general categories, but it doesn't mean something that's traditionally used is the only thing available. And that's why I say it's endless. There's endless possibilities for tools in the toolbox. The goal is to suppress, eliminate, and in some cases tolerate weeds, so we might not necessarily need to eliminate them. Working with the natural processes that are out there. And so we have a number of different kind of fundamental principles that are related to this. We've got, make sure we're using in some cases, action thresholds, where if we know when a situation is reaching a point where we have to apply something, then we can do that. As well as economic thresholds. When is it economically viable to make an application? And then also balancing this with the biology. So the weed seed bank, we obviously don't want to contribute more seed to the seed bank. That's really not the purpose. And we also want to maintain, again, this harvest efficiency kind of idea. So I think this is a really nice continuum if we're talking about, the tools of integrated pest management or integrated weed management, and where an individual, where you might occur on this continuum. So if you start at the top where there's no integrated pest management, you're just using one tool over and over and over, all the way to a very bio-intensive approach to integrated pest management or integrated weed management. Now this is not to say something's right or wrong, good or bad, it's just the reality of the situation. Sometimes you're in a condition where you might not have a lot of tools to work with, or you might have a lot of alternatives that you can think of using. So that's where thinking, how can I integrate my approach, will move you down this continuum. All right? So similarly, when we're talking about tools, we got to talk about the region. And so when we talk about a region, and I'm talking geographic region, that affects the availability of tools, it affects the type of tools, and it affects the utility of tools. So just thinking about climate and crops. If we talk about precipitation, and this is a main driver in the approach that when we're talking about cover crops. If you look at the first four regions, the Northeast, the Midwest, the Southern, and the Mid-Atlantic, annual precip ranges from 32 inches to 60 inches. That's a lot of water. If we got that much water in Utah, this would be a vastly different state. We're at around anywhere from, in the western U.S., between 9 inches and 22 inches, and in Utah, it averages 12 to 15 inches depending on where you are. So these are averages. But the emphasis is to notice, which you probably already do, not a lot of water out here. So what does that mean? If we're going to look at cultural tools, we need to think about how to go about doing that. But we can't necessarily just say, well, let's just eliminate those because we don't have enough water here. No, let's look at maybe there's a way to use those, and that's really the emphasis of the research that we did. So just to review, what is a cover crop? I think you guys all know this, but just to make sure, you know, it's looking at a crop that occurs between that cash crop that you're growing, and it provides a way to improve productivity. What types of plants can we use as cover crops? Basically any plant you want. You could use a weed as a cover crop if you could get it to function that way. Now there's some limitations there because weeds do things that we don't like, but it's that idea of putting something there that is going to increase productivity for the crop, the desired crop. So it's determined by how it's used rather than its species. So why plant a cover crop? Provides a way to retain water and help prevent erosion. Also allows us to increase the microorganisms in the soil, and that affects the way the crop grows and its viability. So specifically, and these are some of the things, I think this probably is, you guys are aware of this. I'm highlighting the weeds because that's really where I work. But there's a number of different things that I think we all know are important and really are why we use cover crops. I want to show an example of a grower from the in the Northwest, the Pendleton region, Mr. Noah Williams and Mr. Garrett Dyke. Mr. Williams is the grower, and Garrett is the NRCS person there. Does anyone know this individual? Maybe you've seen. I think there's a clip online you can watch. He talks about what he's doing, but he's actually using cover crops, or he's trying to incorporate cover crops into his dryland wheat system in eastern Oregon. Really an interesting way of doing this, but trying to think differently about the system. So typically what they use is a chemical fallow approach. It's basically to minimize erosion, but there's not a lot of other other soil health and improving performance features of this approach. So can cover crops be used as an alternative? Obviously, there's the benefits that we know about, increasing organic matter, things like that. But it's largely avoided due to the risks of soil water use and depletion. That's probably the number one reason why people are not really excited about cover crops in the West, is what's it going to do to soil moisture. Okay, so they're in a 2-year study, I believe they're in their 2nd year, looking at what is the effect on soil water, crop yield, and soil health. They didn't look at weeds, I'll do that, but I want to show you this is just one example of some research that's going on. Okay, they did a number of things. They installed soil moisture sensors. They looked at livestock to terminate the cover crop. They kind of looked at a side-by-side approach. And what did they find? Well, in their results, the part that I underline, it's basically, it's going to take several years to see improvement in the crop yield. So if you look at that little box at the bottom, you can see where it says 2017 yield versus the difference from the 2-year yield average. So in their chemical fallow winter wheat production, they're increasing. That's the green. You see the green, that's good. The red, that's not so good. So where they've got the cover crop winter wheat, you see they're off. Where they've got chem fallow spring wheat, they're up a little bit. Cover crop spring wheat, it's up a little bit too. So it wasn't an overwhelming, oh, we made this huge profit now because we incorporated cover crops into our system. I think if you've been in farming, or if you've been growing crops long enough to know it doesn't happen overnight. And what they're trying to show is that over time, they can incorporate cover crops into their system where it works. I think you can see in that field, not every part of the field is going to work for this system. The other thing is, so what happened to the soil moisture? Well, so this graph shows you the trend in the cover crop part versus the chem fallow, and you can see it tracks pretty closely. And it tracked pretty closely with whether that was at 6 inches, 12 inches, or 24 inches. And so there is a fairly similar trend in water use, water availability between these two systems. Not as big of a surprise as you might have thought. Okay, so that's kind of the impetus for what we're doing to try and look at, can we use cover crops? Can we alter plant spacing? Can we alter seeding rates in this Intermountain West region? So our study sites, we're at Kaysville, Cache Junction, and Kimberly. And so we were working on ag experiment station fields. So where I'm going to show a pic where we had to actually spread weed seed. That's a really challenge. I work in weeds, so not a lot of people really like that. I understand that. That's why we have experimental farms. I even get a lot of feedback from those folks. So, but these are really important to help us kind of do this research. Kaysville, Kimberly, and Cache Junction. Okay, so our crop was irrigated spring wheat. The cover crop, we used crimson red clover at 25 pounds per acre. This is broadcast applied. And our experiment, we had 16 treatment combinations. So we were looking at seeding date. We had 2 dates of planting. We had 2 different rates of wheat planting. We planted 2 different rates. And then we had 4 different weed control treatments. So that gave us 16 total. And so what did we have to do? Or the details, I'll just put these all up here. So our seeding dates were as soon as we could get into the field. So we called that our week 0. Cache Junction, if you know anything about Cache Junction, that delayed us quite a ways into the season, but we still got in there and we planted. Red clover, again, we planted at 25 pounds per acre. We planted as a relay interplant cover crop, so we planted it with the wheat. We didn't put it in the planter, but we broadcast it at the same time. Hard red spring wheat, you can see the 2 varieties. We planted 100 pounds per acre and 150 pounds, which was our high rate. And then we actually had to seed kochia into our plots to make sure we had a good population of that. Surprisingly, that is one of the things we had to do. Herbicide treatments, we applied Husky at 16 fluid ounces per acre, and we also used MCPA as part of our cover crop herbicide treatment. Some of the data we collected, we looked at efficacy, percent control, we looked at number of kochia and other weed species. We also did wheat stand counts. The things that I'm going to talk about is the yield, the biomass, and the percent cover. And I'm not going to cover everything. I'm going to cover just a small part of this. There's some other things that we want to study, looking at light penetration, plant phenology, some differences in germination, but that will be more for our graduate student who's part of the project. Okay, so I like to show this picture because it really emphasizes what we're doing, the two forces at work, if you will. I hate to use the Star Wars analogy, but the good and the evil is part of this maybe. The bags, you see those plastic Ziploc bags, so the one on the left, that's the kochia seed, and the one on the right, that's the clover, the cover crop seed. Okay, so the cover crop seed, that bag is completely full. The kochia, there's barely anything in there. And so this tiny little seed, this little kochia is there, and now we're going to put as many tools as we can to try to help control it or suppress it or prevent it from being an issue. Okay? Well, so we don't want this to happen. We don't want all our efforts to be this minuscule little effort, and then we have kochia becoming this huge force out in the field, which unfortunately I have seen that in some cases, but we're trying to avoid that in this one. Okay, so as I was saying, our experiments, we had 2 sites, Kaysville. This just shows you the activities that went on throughout the season, where we planted. We did a number of data collection points, tried to make sure we were counting, collecting cover. We did stand counts, as I indicated earlier. We harvested on July 18th. So that was the grain harvest. So we were just harvesting the grain. And then we came back at the end of the season and did a biomass harvest to look at what was the remaining biomass of the cover crop. Same thing at Cache Junction. Same idea. You can see, look through there when we made our spray application. There's different dates when the water came on, when we were irrigating, and then different times of data collection. The thing with the water, one of the challenges was, especially with wheat, so you got to dry the wheat down, right? You got to dry it down in the summer, but yeah, you have this growing clover crop. So if you turn the water off to dry the wheat down, is that going to kill your clover? If you keep the water going to keep the clover going, are you going to affect the harvest quality of the wheat? Well, interestingly, if you plant the clover with the wheat, it has a pretty well-established root system, so we could cut the water off, and it really did not affect the clover, which was really a surprise to me because I thought for sure the clover was going to die, but it actually did pretty well. Okay. So I think we're going to go to some results here. Hopefully it changes over. Yes, results. Okay. So these are results from Kaysville and Cache Junction. Again, I didn't include anything from Idaho. That would have been made this talk twice as long as it needs to be. Basically, I just want to give you a little taste of kind of what we're seeing. And this is yields, so bushel per acre. Again, and this is from Kaysville in the yellow, Cache Junction in the blue. And if we look at the effect of weed control, so primarily that was the focus, is what was the effect of weed control. And if you look, it's really interesting at Kaysville where we saw herbicide was probably our best treatment, but the cover crop was, even though a little bit lower, was not significantly different. So we saw a pretty comparable response there. As far as adding the MCPA to the cover crop, it wasn't not as effective as we thought it might be. Going to Cache Junction, there was basically no effect. Weed control across was pretty uniform. Talking about the effect of planting rate. So our 2 different rates. This is 100 pounds per acre, 150 pounds per acre. You can see that, and this is be intuitive. You plant higher rate, you expect a higher yield. We saw that at Kaysville. We didn't see that at Cache Junction. What we saw there was the effect of planting date, which is, like I mentioned, it was a bit of a challenge to get into the fields there because of the soil and the water. But when we got in early, we saw higher yields for the planting date, week 0 versus week 3. Now looking at percent cover, and this is just at Kaysville. If we look at cover, and you look at the amount of weeds, so we're trying to prevent weeds, and this is mid-season. This is June 13th, probably not this is late in the season. We've got a month left or so before we harvest. But if you look at the weed numbers, so look at the yellow bars. In our cover crop plus MCPA, we saw really good, a lot of really minor number of weeds. Saw a really nice population of the clover. If you look at the cover crops, same thing. But then if you look at the herbicides, you see that was probably the second most number of weed species or weed population. And you also see that there's a lot of bare space in that treatment. So you're taking out a lot of plants, and you're opening up opportunities for weeds and other things to come in after, later on in the season. Okay, so I think this really emphasizes how we're seeing this competition effect from the cover crop. Same date, and same thing, we're looking at percent cover, looking at the effect of planting rate. So at our low planting rate versus our high planting rate, you can see weeds are in the yellow, the clover is in the light green, the wheat is in the blue, and then our bare ground is in the dark green. And so at the lower rate, we saw more of an establishment of the clover than we saw at the higher rate of wheat. And that would kind of make sense. If you're going to put more plants and more crop in there, you're going to have more of a competitive effect on the clover. If we talk about the planting date, again, percent cover, if we look at our week 0 versus week 3, the number of weeds, again, if you get in early and you can get the plants established, they're going to be more successful than you would late. But this is not real clear at this point. We still need to do some more research, and we're going to, again, like I said, this is the first year of the study, so we've got a number, at least 2 or 3 more years, at least 1 or 2 additional years that we're going to pursue this. Looking at the end of the season, so we've looked at yield, we've looked at mid-season cover, now we're looking at end of the season biomass. So when you have a cover crop and you let it go to the end of the season, what does it look like? Okay, we had excellent stand of clover in our plots. And this is biomass in a quadrat. But you can see that the compared to the wheat, and you would expect that because we've already harvested the wheat, so there's no grain there. There's a minor contribution from wheat in the yellow bars. But the number of weeds, you can see in these, where there's cover crops, were reduced. Where at our herbicide and our control, there's more weeds there. So we're seeing this direct competitive effect and showing how well, in this case, clover does in this system, looking at the effect on weed control. Now, if we look at the effect on, I think, planting date. Yep, planting rate. Again, so we're seeing that this low planting rate versus the high planting rate, more clover in that lower one because, again, we're planting a lower rate of the crop. Planting date, same thing. We see earlier planting, we see a higher biomass of the clover, and the weeds really don't change in this one versus date. But again, this isn't really clear. We need to kind of look at this some more. So what does this mean after 1 year? Well, we didn't see kochia exploding like we might suspect, but we didn't see it staying as this little innocent little plant. It was probably mid-range. What was our most effective treatments? So again, a combination of treatments, but clover and herbicides seem to be the biggest factors, and there's a number of other factors that we're trying to tease out as far as what the effects were on the wheat, or on our yields. Okay, so in summary, clover seeded with irrigated spring wheat, so the yields were second to herbicide alone. We did very successfully establish the clover, and it was very competitive against the weeds. It continued to grow throughout the season, even though the amount of irrigation was diminishing. We didn't look at things like soil nitrogen, microbial contributions. Those are other factors that are going to be important. What we are looking at is looking at legacy effects. So where we had our study this year, we're going to go in and just plant a crop and maintain and remember or identify where our plots were and see what is happening to that next year's crop. Are we seeing increases in yields? Are we seeing any differences that way? Clover seeded plus herbicide, there was no apparent benefit of the herbicide except where we had bindweed. And the planting date, seeding rate, it wasn't consistent after 1 year. So again, we need to do some follow-up studies on that. So that's the end. I'd just like to acknowledge some folks from Utah State. I had a lot of graduate students, undergraduate students helping on this project. Really great farm supervisors, University of Idaho Weed Group. I'd like to acknowledge the funding. Came from the Western Integrated Pest Management Center. And then Utah Seed provided the clover and the wheat seed. So please fill out your survey. That sheet I believe you have in your packet. That's really helpful for me to kind of get an understanding of what you guys are thinking as far as cover crops in this area. It's completely anonymous. You do not have to put your name on it at all. And if you want to receive updates from me, just send me an email. I put my email address on there. You will not receive a Survey Monkey. You will not receive a whatever the latest thing is. You will receive an email directly from me about cover crop research. So if you're interested in that, contact me. But please fill out your survey. You can put it here or you can give it to me sometime before the end of the workshop. Looks like we've got about 5 minutes for questions. So anyone have some questions that you want to ask? Anyone, are you all using cover crops? No? Yes? Thinking about it? Yeah.
So you didn't do any soil samples on that clover compared to the other yet?
So the question was, I didn't do any soil samples on the...
See what kind of end you have left in the soil after the year's over?
Yeah.
Over the non-clover.
Right. No, we didn't do that. That's a really good point to see what kind of nutrients are there. And part of that we'll be able to pick up indirectly in the next crop. That's not the best way to do it, but that gives us kind of a visual to see that what has happened. But I think definitely going in there and sampling to see what the result was. So we planted at 25 pounds per acre. I know that's at the high end. Is anyone planting at that rate? Maybe not. I know that the last group, there's folks looking at like 18 to 22 pounds per acre. So we saw such great establishment at that rate that we're thinking of looking at different rates of in this case, clover, to see, is there this kind of threshold where you got to be at least have this many pounds per acre? Any other questions? What's that? Dyer's woad. So a question about Dyer's woad. Oh no, it's still there. It's just not in cropping systems. At least not where it's in. In the hills and areas where rangeland and those kinds of areas, field edges probably, borders. Oh yeah, it's doing great. We're working on that too, though. Yeah. So the question is, have I seen any improvements in Dyer's woad?
Decreased Dyer's woad in areas that it's been grazed versus non-grazed.
Okay, where it's grazed and non-grazed. Not to my knowledge. No, I don't believe so. I know our approach is to look at, can we reestablish something that's desirable once it's taken out? So whether, revegetation strategies, looking at different competitive, not annual grass, but native or desirable grasses. So that would be something we're doing, but I'm not aware of if it's declining based on grazing.
We just noticed behind us where it's non-grazed, there's not grazing, it's a lot more Dyer's Road versus other areas that have a field
Yeah,
that pops the seeds off.
yeah. So I'm not. So do cattle eat the Dyer's Wood seed
I've never seen it till this year, and they went through when the seed heads were
when they're black?
soft, right before it flowered.
Really?
They cut the tops off of them. I've never seen it before.
Wow. Okay. So
The cows, I don't know, it was weird. That's why I asked, because I've never seen it before.
yeah. That sounds like, were they goat hybrid? Okay. So cows eating Dyer's Woad seed. I have not seen that. Okay. Okay. Anything else? What weed causes the most damage in Utah crops? Anyone else want to tell me before I? What was that? Bindweed. I think he's right. Yeah. Yeah. The roots go down like what, 50, 100 feet or more? My predecessors looked at bindweed roots and that kind of thing, and so it's a challenging one, but I think the idea of competing with it, can we get something in there to outcompete it? What is that? I don't know. Maybe it's a hairy vetch. Anyone else? Okay, I think that will end it. So be sure to get your surveys to me if you can. I really would appreciate that, and thank you for your time.